to those at the end of the unit actually, so that you see how they're proven. And then with the exponential and logarithmic functions, again, we discovered those numerically. We graphed the derivative values because we have these super cool calculators. We can do that. And then we looked for patterns. So now we're getting into kind of a different beast. We're saying, hey, sometimes we have functions where they are a product of two expressions. How do we find the derivative of that? Okay, so again, new type of function, new type of derivative rule. So these notes then have to do with the product rule for differentiation. And the essential question is, how do we calculate derivatives of products? So before we jump into that, let's just do a little bit of a review. Derivative of e to the x is itself e to the x. Everywhere where we see every point on e to the x has a tangent line with the same slope. It's kind of cool, actually, if you think about it. Derivative of the natural log of the absolute value of x, because we're talking about only positive values in that first and fourth quadrant of x, is 1 over x. So when we numerically found the derivative of the natural log of the absolute value of x, we noticed that it was always the reciprocal of whatever we had in this location. So that's also kind of cool. All right, back to what I would do in all unit, right? When I say derivative, you think slope. When I say slope, you think derivative. Okay, so what is the derivative of this product? So here is two things multiplied together, right? We have this function, x cubed plus 4, right? That looks like x cubed and then moved up 4. And this one is 7 minus 3x squared. So it's an upside down parabola. And we're multiplying these together. Okay, so let's talk about some strategies here. We don't have your PodMate handy, but you could phone a friend if you wanted to. So some strategies here that we could do to differentiate this. These all look like powers, so we could FOIL it and do it term by term. That's certainly legal. Okay, so let's go ahead and do that. So we take x cubed times 7 minus x cubed times 3x squared plus 28 minus 12x squared, right? So that was firsts, outside, inside, lasts, right? We FOILed it. Well, now we don't have any brackets. We don't have any products of polynomials. We can just go ahead and take the derivative of that term by term. So what's the derivative of 7x cubed? Bring down the power, multiply, reduce the power, get 21x squared. What's the derivative of minus 3x to the 5th? Bring down the power, reduce it, got minus 15x to the 4th. What's the derivative of 28? It's a constant, so that's 0. Not even going to write it. What's the derivative of this last term? Bring down the 2, multiply it, reduce the power, get negative 24x. So there's the derivative. So we know this is true. Okay, we can always FOIL stuff out. And in this case, it makes sense to. It's not that hard to FOIL. I wouldn't do this problem any other way, by the way, but it is going to provide us the foundation to work with products. And since we know the answer, we can check our work. Okay, so we know that that's the correct answer. Now, let's do a little investigation here, a la note style, and ask ourselves, is this the same as the product of the derivatives? So in other words, let's take a look at the play on words I'm doing here. Is the derivative of a just the product of the derivatives? Is that you see the play on words there? Let's try this and see if it works. Well, if we're going to take the product of derivatives, we need the derivatives of each one of these things. So what's the derivative of x cubed plus 4? We know that that is 3x squared. What's the derivative of 7 minus 3x squared? We know that that's minus 6x. So let's multiply, right? We want the product of the derivatives. Here are the derivatives. The product means multiply them together. So when we multiply those together, we get negative 18x to the 3rd power. Well, we know this is the correct answer. This is a viable solution. This is how I would solve it, actually. This is how I would take the derivative. So this is not that. So this is not correct. So we can't just take the product of the derivatives. We have to do something else. Okay, so put an X, big X through that in your notes. Nope, this doesn't work. Scribble it out. Do what you have to do in your notes. Okay, to get your eyes to realize that when you're reviewing your notes, you just skip over this. This is a false start. There's nothing wrong with having false starts. Sometimes you think, hey, let's try this, and it doesn't work out, and that's okay. It's part of the learning process. So we're going to get rid of that. So a couple of things before we move on that I'm noticing here is this is only one term and this is three terms. Okay, this is only x to the third, and this is an x to the fourth. If we noticed our polynomial is really a fifth degree polynomial, we know derivatives reduce power, so it makes sense to have a fourth degree polynomial as the answer, or at least part of the answer to the derivative. So this is making less and less sense. The negative 18x cubed is making less and less sense as we go along. Okay, so we're going to get rid of that. And now we're going to try something else. What if we take the derivatives each separately and multiply it by the other function? So in other words, I'm going to take the derivative of x cubed plus 4. Okay, that's 3x squared. We already discussed that. I'm going to take that 3x plus squared, and I'm going to multiply it by the other product, okay, by the other function. Okay, and then this derivative is minus 6x. So I'm going to take that 3x squared. So this is the derivative times what was left here, right? And this is what was originally here times the derivative. I'm going to slide that over there. Okay, so let's take a look at that. And I'm kind of leading you here for a reason, right? So doing this multiplication up top here, we get 21x squared minus 9x to the fourth. Doing the multiplication down here, we get negative 6x to the fourth minus 24x. Well, those are starting to look like familiar terms, right? I got the right answer up here at the top. Well, what happens if we add those together? Then we combine like terms. So we get 21x squared minus 9x to the fourth minus 6x to the fourth is minus 15x to the fourth minus 24x. There it is. Here is the process. It's a little clunky, but that's what gets us the right answer. Okay, so let's diagram what we just did here. So don't take notes quite yet. Okay, let's call the first product U, and let's call the second part of the product V. So in essence, our original question was U times V. Okay, we needed the derivatives of each one of these things. So we needed a U prime and a V prime. So, but we took our U prime, here's our U, right? So this is our U prime. We took our U prime times V. And then this down here was our U and our V prime. We took those and multiplied them together, and then we added all that up. So this is the definition of the derivative of a product. Okay, so now we're going to diagram that. All right, so let's get this definition down. Now notice this definition has U's and V's because it represents the stuff in each one of these brackets. Maybe I should have put a little bracket here and a bracket here. But, and we're using this notation for prime for the derivative. Okay, so let's diagram this one out here. Notice that this is not just the product of two derivatives. Remember, we tried that and it didn't work. Okay, so we're taking the derivative of this product. So don't write this down. I'm just going to FOIL this out. There's my FOIL. There's my derivative, and there's my answer. Okay, right? 10x to the fourth, 10x, 18x squared, 0. Okay, this is just like we can check our work. Okay, so we're going to call this U. We're going to call this V, and we're going to apply this definition. So I need U prime V plus U V prime. So derivative of this, U prime. Okay, that's 2x. times v times this, 2x cubed minus 5. Now I need u, which is just this, x squared plus 3, and I need v prime. So I need to look at this and differentiate it in my head. So I got 6x squared, and this will be 0, so 6x squared. So now I have u prime v plus u v prime. So let's simplify this. Let's distribute this. So that gets us 4x to the 4th minus 10x. Let's distribute this. That gets us 6x to the 4th plus 18x squared. Let's combine our like terms. Where do we have like terms? We have the 4th degree terms here. 10x to the 4th. Look at that. Oops. I slid that a little bit too much. So sorry. Hold on here. Let me back this up a little bit, maybe to here. And let's back this up. Maybe to here. A little bit higher. A little bit higher. There we go. Okay, sorry about that. Can't seem to get through a whole presentation without a mistake. See, I have lots of false starts, and I just keep plugging away and correcting my false starts. No big deal, right? Okay, that's better. Okay, combining these like terms, 4x to the 4th plus 6x to the 4th is 10x to the 4th. Then I got a minus 10x, and I got plus 18x squared. So that is what we FOILed out here and differentiated term by term. Okay, so this is the product rule. This is really handy. Not so much for problems like this. Honestly, I would still do problems like this by FOILing. But I'll show you where this definition really comes in handy. We've got one more thing to do here. We have to evaluate this when we plug in 1 for x. So we're going to do that now. So we are going to plug in 1 for x. So we're going to have 10 times 1 to the 4th minus 10 times 1 plus 18 times 1 squared. So that's just really 10 minus 10 plus 18, right? That's just 18. So the derivative or the slope of the tangent line is 18 when we have this function and we look at x equals 1. Okay, this is where it's handy. This definition allows you to work symbolically. So we're given 4 values here. We're given u and u prime and v prime, and we just need to put it together here. Let y equal u times v. Okay, it's the product of function u and v. Use the product rule to find the derivative of y at 2. Okay, so we know, let's organize this information. I'm just going to organize it in a table. When x is equal to 2u, the function u is equal to 3. The derivative is equal to -4. When x equals 2, function v is equal to 1, and its derivative is equal to 5, right? I'm picking those values, all those function values. That just helps my eyes. Okay, so we know that y is the product of u and v. So now I'm going to use that definition. Okay, so I know this is u prime times v plus u times v prime. Okay, so I'm just going to grab these right out of the table. What is u prime? It's -4. What is v? It's 1. What is u? It's 3. And what is v prime? It's 5. So this is where the definition is really handy. And so mathematically, that's -4 plus 15. That's 11. So the derivative y prime at x equals 2 is 11. So that's how this definition can be used to find answers super quick. Let's look at a graphical representation. Okay, let function p be function f times function g. Okay, let that be the product of f and g. Use the product rule to find p prime of 2, the derivative of p at x equals 2. Okay, so right here. That's all we're focused on. This is doing all sorts of crazy stuff. We don't care. We just care about right here. Okay, so I drew that dashed line down my graph just to focus. But kind of like creating the table on the last problem. It's just helping my eyes focus. Okay, so those are nice strategies to help you focus on the important information. Okay, so we know P prime then is F prime times G. Now we have F's and G's instead of U's and V's. So we're going to have to improvise here and be okay with working with different variables. So F prime times G plus F times G prime, right? One derivative at a time. Okay, well, I say derivative, you think slope. So what is F prime? It is the slope of function F right here. Okay, so we can count the squares and we can figure out a slope there. Okay, so that slope is 1, right? It goes up 1, right 1. Now, G is a function value. So we go down to function G and we grab this value right here. We're going to have to kind of best guess it here. It's not 4. It's not 3. This is linear. So I'm going to go with 3.5. Okay. That point right there, 3.5 is 7/2. I just wrote it as a fraction. Okay, plus function f. What is the function value up here on function f? And that is 7. And g prime means I need the slope down here on function g. It looks negative to me, right? Let's go down 1, right 2. So it's negative 1/2. Okay. So what do we have here? 1 times 7/2 is 7/2. 7 times a negative half is negative 7/2. Holy smokes. I found where the derivative is equal to 0. So the derivative of that product is equal to 0. Okay. Now, an interesting exercise would be to take the product of all of these function values and multiply them together and graph that and see what the slope was at 2. And somewhere at 2 here, you're going to find out that you either have a hill or a valley, right? Some flat spot, because we found the derivative equal to 0. It'd be kind of a cool exercise. Okay, so when we get in the classroom, we'll go over the takeaways from the notes, address any questions, and we'll, I think we got both topic questions and a circuit to do. A lot of extra practice, which is good to get comfortable with the product rules.